Okay, dear. So we are going to start the BGP protocol for now. Okay. And this is the most important topic in the CCNP. Basically, if I talk about the BGP protocol, that is that is mostly preferred for the IGP protocol, EGP protocol, right? What is the meaning of EGP? EGP is exterior gateway protocol. Okay. So how how we decide that which protocol will work as EGP, which protocol work as IGP? Okay, dear. So there are lots of factor on the behalf of that we can consider that which protocol will work for the IGP and which protocol will work as the EGP protocol. Okay, dear. So we have two types of
Sir,
protocol. Yes, dear.
route filtering will do it later.
Yeah, we can do that later. Don't worry, because this topic is important and I have to finish this one. That can be done anytime. Okay. So later on we are going to do that. Don't worry. Whenever we will have time, we can do. So that's just the basic topics. So there are two types of protocol over here. First one is known as the IGP protocol, that is called Interior Gateway Protocol, and second one is what? EGP protocol. So if I talk about the preference, so IGP protocol prefers routing information protocol, EIGRP, OSPF, and we can also do the static route in this scenario, right? Well, we are currently discussing about the dynamic routing protocol, so let's remove this one. And EGP protocol, so the best protocol is BGP, but how we decide that which protocol can be used for the IGP, which can be used for the EGP? So there's a factor called administrative distance. Administrative distance. So this factor is the factor that decide which protocol can be used for the IGP and EGP. Okay. So here is we have the protocols. Okay, what are the protocols? Routing information protocols. Okay, EIGRP, OSPF, and BGP. Let's compare them all. Okay, so the AD value for IGP and AD value for EGP. Okay, AD value for EGP. Okay, let's compare all these. So whenever we will do the comparison, so routing information protocol has an AD value of 120 administrative distance and secondary AD value is 120 for external. For EIGRP, the AD value is 90 and the AD value for external is 170. That we have seen in the external route during the redistribution. Okay. For OSPF, AD value is 110 and this is also 110. For BGP, internally we have an AD value of 200, but for the external networks, for the EGP exterior, we have 20 only. Well, the rule says that lesser the AD value, more preferable will be the protocol. Okay, more trustworthy protocol. Okay, protocol. So that it means if any of the uh, protocol has having the lesser AD value, so that is most preferable. So if I talk about for the local area network, so these two protocols are best. Okay. For the wide area network, so this is really a very good protocol for the wide area networks. Okay. And we are going to discuss about this part also. Why is it so? Okay. And another point is that if I talk about the wide area network, so wide area network can have million of route, right or not? It can have million of route for the wide area network. So, so is it possible that a protocol like routing information protocol that can hold the route up to 15 hop count can work for the wide area network? No, routing information cannot work. Routing information protocol cannot work. EIGRP is also limited to what? 100 hop count, and we can extend up to 255. So we will clearly say no, that is also cannot use for the wide area network. OSPF is having the unlimited hope count, but we have a problem with the OSPF that is called link state advertisement, and the updates must be identical for all the networks. So that is why we can maximum hold the routes up to 1000 hopes in this 1000 route can be there in the table. So after that, it will be overloaded. Okay. So that is why OSPF cannot be used for the wide area network. The only protocol that is called BGP is the best protocol, and it can easily maintain million of routes very easy, because on internet currently there are 7 lakh plus routes available. So all of these routes can be maintained by the BGP protocol very easy. So that is why we are using the BGP protocol over the wide area network. So this is the best protocol to communicate in the wide area network, right? Now, we were discussing about the difference between IGP and EGP. Okay, dear. And we stuck over a concept in our last class that was reachability, that you was talking about. What is the reachability, right or not? That how the BGP protocol behaves in the same autonomous system number, right? If you do remember. So let's talk about the reachability, right? So first of all, we will do the communication in IGP, that is called IBGP, BGP that will be used for internal, versus EBGP. What? EBGP. So we are going to do the comparison and configuration for both IBGP and EBGP. Okay. Then we'll see that how the both protocol will behave. Okay. Well, both of these are from the BGP protocol, but they are behaving differently for the same AS number and different AS number. So let me go to GNS3 now. Okay. So let us assume we have three routers again, like, okay, on these, let us assume all of these three routers are connected via cables FA0/0 and FA0/1. They are connected like this. Okay. Okay, dear. So these are connected just like this. And let us mention the network. The network in between them is 192.168.10.0, and the network in between R2 and R3 is 192.168.11.0. The IP address on R1 is 192.168.11.1, 192.168.11.2, and on right side this is 192.1, oh sorry, 10. This is 10.1, and this one is 10.2, 192.168.11.1, and 192.168.11.2. Okay. So this is what we have in network. Let us assume we have multiple loopback IP address for the testing. Let me mention them all. That is 10.0.1.1/24. Okay. 10.0.2.1/24, 10.0.3.1/24, and 10.0.4.1/24. Okay. Let us assume on right side we have a network that is 10.0. That is 20.0. 1.1, that is 20.0.2.1, 20.0.3.1, and 20.0.4.1. We do have all these. Okay. So first of all, we are going to provide the IP address. Then we are going to do the configuration of BGP over here. Okay. So let's go to router number one, configuring terminal. Okay. Interface. Which one is this? Loopback 1. Interface loopback 1. IP address is what? 10.0.1.1 and 255.255.255.0. Interface loopback to 10.0.2.1 and 255 and so on. 10.0.3.1 and loopback IP address. Okay. 10.0 dot interface loopback 4, 10.0.4.1. So we have just provided the IP address for all the loopback IP addresses. So interface F0/0, no shutdown. Okay. IP address, that is 192.168.10.1 and 255.255.255.0. So we have just provided the IP address on router number one. Let's go to router number two. Configure terminal. Interface F0/0, no shutdown. IP address is 192.168.10.2 and 255.255.255.0. Okay. Interface F0/1, no shut. IP address is 192.168.11.1, 255.255.255.0. Let's go to router number three. Configure terminal. Interface F0/1, no shutdown. IP address is 192.168.11.2, 255. Sorry, 255.255.255.0. Okay. Interface loopback 1. IP address is 20.0.1.1. Okay, and 255.255.255.0. Interface loopback 2, 20.0.2.1. Okay, interface loopback 3, 20.0.3.1. Okay, interface loopback 4 and 20.0.4.1 and so on. Okay, dear. So we have the just provided the IP address over here. Now, let us assume all of these are in same AS number. Well, that is means we are going to configure the IBGP protocol, that is for internal networks. Okay, we are going to configure in the same AS number. That it means we are configuring like OSPF or EIGRP that we have done. So IBGP we are going to configure for now. Okay, the AS number is same. So dear, first of all, let's go to router number one. Here, dear, this protocol does not works like OSPF, routing information protocol, or EIGRP. Because in case of OSPF or EIGRP, we have seen that if we have advertised the network on both the ends like router 1 and router 2, what will happen that they will automatically become the neighbor after forwarding the hello packet, right? But this is not work in case of BGP protocol. If you will advertise the network, they will not become the neighbor. You have to manually create the neighborship in between the routers. Okay. So we have to manually define the neighbors. So go to router number one. Okay. So router BGP 100, right? The AS number neighbor, which one is this? 192.168.10.2 remote AS 100. We have to manually define the neighbor. But before defining the neighbor, let me go to this link and capture the packet. Okay. So whenever I will put this command, okay, the router will start forwarding the message. Which message there? That is called TCP message will be start forwarding. So what is this TCP message? Dear, if you do remember the three-way handshake, what? Three-way, three-way handshake. In the three-way handshake, the routers, the two devices were forwarding the sync signal, and in response of that, acknowledgement was forwarded. So this is the same messages it will forward. First of all, it will forward the TCP message, and then it will it will receive the acknowledgement on other side, right or not? So TCP message will be forwarded. So the point is that the packet generated has a destination port number. That is, destination port number is what? 179, right? And source port number is a random number, right or not? Sometimes it is 58842. So dear, the source port number is, you can say, undefined, or a random port number can be taken by the BGP protocol. Okay, let's go to this side. So you will find that the source port number is a random port number, but destination port number is what? Is a specific number that is designed for the to find the TCP or the BGP neighbor. Okay, so that is used to find the BGP neighbor. Okay, dear, let me minimize this. So we have just advertised the just we have provided the neighbor information. Let's advertise the network, that is 192.168.10.0, and mask is 255.255.255.0, and network available on this side are 10.0.10.0.1.0, and mask will be 255.255.255.0, 10.0.2.0, and mask will be this side 10.0.3.0 and 10.0.4.0, and so on. So we have just provided the subnet mask and the network information. So dear, let's go to router number 2. So router BGP 100 neighbor 192.168.10.0, and mask will be 2, neighbor is 10.1. Okay, and remote AS 100. We are providing the neighbor information. When we will provide the neighbor information and advertise the network 192.168.10.0, and mask will be 255.255.255.0. So whenever we will provide the network information, the adjacencies will be up. So we are creating the manual neighborship, and when we will create the neighborship, you will find lots of messages will be forwarded. So dear, in case of OSPF, we have seen hello packet that is used to create the neighborship, right or not? No need to discover, discover or create neighbor, right or not, dear? Hello?
Yes, sir. Yes.
Yes, but in case of BGP, it will only share, it will only forward a single open message to to create the neighborship. These two messages will be forwarded as the hello message, and in case of BGP, they are known as the open message. What? Open message that is used to create neighborship or initiate the neighborship, like we were doing in case of what? OSPF protocol was forwarding the hello packet to create neighborship, right or not? So here we have open message that is used to initiate the neighborship, and we have seen that the OSPF was continuously multicasting the packet, that was hello packet. It was continuously multicasting for to maintain the neighborship, right or not? To maintain neighborship, right? If you do remember. So routers were exchanging The hello message is for maintaining the neighborship, but the BGP protocol does not works just like this. It will forward the keep alive message. What? Keep alive message to maintain the neighborship. What? To maintain neighborship. Okay. So in case of OSPF, we were using these two packets, hello packet and this one, to once to create the neighborship, one to maintain. But in case of BGP, we have open message to create the neighborship, and keep alive message will be forwarded to maintain the neighborship, right or not, dear? So that is what we got the packets in case of BGP, that to maintain neighborship, it will continuously forwarded the keep alive message. Later on, we are going to see that below. Then the update messages will be forwarded to exchange the network information, and then it will start forwarding the TCP and keep alive message. So keep alive message, you can see, will be forwarded after every 60 seconds. The routers are exchanging the keep alive message, and these are not multicast. What? Not multicast. So this protocol does not do any multicasting, and these two packets will be forwarded from in between source and destination, and source and destination, right or not? So they are unicasting, not the multicasting. Clear? So keep alive message will also be unicast, not the multicast. Okay, dear? From IP to IP, it will be forwarded. So that is why that is called keep alive message. Okay. So in case of any of these messages of the neighborship, you will not see any multicast packet, because this protocol is 100% reliable and do the unicast over here, right? So all the packets are in form of unicast, right or not? If I ask you what was OSPF doing, OSPF was doing the multicasting, right or not? What was the multicast address for OSPF, dear? Hello?
Right. Right, sir.
224
Right. You're typing right.
224.0.0.5. So that was the multicast IP for the OSPF, that is 224.0.0.5. So can you see any multicast packet here, dear? No, there is nothing like multicasting here. No multicast packet will be forwarded. Only the unicast will be done. Okay. Now let's get back to our network. So this is how the BGP protocol behaves. Okay. Now let's create the neighborship in between R2 and R3. We have to manually create the neighborship, right? So neighbor, which one is neighbor? 192.168.11.2 remote AS, which one is this? 100. So we are dealing in same as number, remote AS 100, and network will be 192.168.11.2, and mask will be 211.0, sorry. Mask will be 255.255.255.0. Okay. Let's go to router number 3. So router BGP 100 neighbor 192.168.11.1 remote AS 100 network is what? 192.168.11.0 mask will be 255.255.255.0. Okay, dear. Network available on this side is 20.0.1.0, and mask will be 255.255.255.0, 20.0.2.0, and 20.0.3.0, and 20.0.4.0. Okay, 4.0. So dear, we have just configured the networks over here and create the manual neighborship in between R1, R2, R2, R3. So let me ask you a question. That will, can R1 able to forward any packet to R3? How we can check that? So can R1 able to forward the data to R3? How we can observe that, dear? So for that, we have to check the routing table. So do show IP route. So you will say, sir, there is nothing like 20.0.2.1, and on R3 routing table, do show IP route. So there is nothing like, uh, so these two network information are not available in R1 and R3, right or not, dear? Hello?
Yes, sir. Yes. Right.
Any information is available? No, there is no information is available. In R1 routing table, we can't find these networks. In R3 routing table, we can't find the loopback interfaces of R1, right? If I will go to router number 2 and put a command do show IP route, so you will find that the network information is available in middle one, but not on others. Not on others. So how we can solve this issue? What is the major issue with that? The problem is that you did not have created the neighborship in between R1 and R3. So you have to manually create the neighborship in between R1 and R3 also. What? You have to manually create the neighborship in between R1 and R3 by by these by these IP addresses. So we have to create the neighborship by using these IP addresses because these IP addresses belong to both of these neighbors. Okay, so let's start with router number one. Okay,
Sir, are we able to ping 11.2 from R1 router 1?
yeah, we can able to do 11.2 but cannot able to forward the data to this side. 11.0 can be advertised but not beyond that. Okay, let's go to router number one. Okay, so we can see that ping 192.168.11.1. So that can be ping 192.168.11.2. So we can ping both of them. But dear, we cannot able to ping any IP address belong to router number 3 or beyond. The problem is that because this is the part of same network, so we can able to share, but these are not reachable, right? And these are not reachable to R3. Okay. Now, what we can do, configure terminal. Okay, first of all, we will create the neighborship in between them, R1 and R3. We have to create a direct neighborship with them. Okay, so how the direct neighborship can be formed? So, router BGP 100 neighbor 192.168.11.2 and remote AS 100. Okay. Now, let's go to router number 3 and provide the information router BGP that is 100. Okay. Neighbor 192.168.10.1 remote AS 100. Okay. So let's advertise the network in between them. Let's create the neighborship in between them. So neighborship will be up now, right or not, dear? Now let's see, can they able to forward the data? So do show IP route. So still we can't see any network information here, right? On R3 also do show IP route. So we cannot see any information of neighbor, sorry, network available in this network. So why is it so? Because in case of BGP protocol, we have to provide the reachability in between the indirect indirect connected routers. So we have to provide this information to these routers. So how we can provide this information to the router by the help of reachability, and reachability will be provided by any other protocol or 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 static route. So this is the method to provide the reachability. First one is you can provide the reachability via routing information protocol. Second is you can configure the EIGRP protocol parallelly. Third is OSPF. And fourth one, you can do the static route to provide the reachability, right or not? Because still these networks are not available in the tables of router 1 and router 2. So router 1 doesn't have any information about these networks, okay? And router 3 does not have any information about these networks. So these information are not available, so cannot able to forward the data, okay? So dear, now you have to
Sir,
pad.
IBGP,
Yes, dear.
sir, IBGP is, I think, not of any use, sir. I think because we required the another protocol in the static routing for the
Yeah,
reachability.
for the reachability, we need
Then
another dynamic protocol, dynamic routing protocol for the same. So that is why
and
that, yes, dear.
and I think do we need to do redistribution as well?
No, we don't need the redistribution. Just you have to parallelly configure any other protocol. Okay. And real time also you have to do that. When we are dealing with the same as number, so everywhere you have to internally configure this one, dear. Okay. So let's go to router number one and configure the OSPF protocol. So closely look over here. We are not having any network information from other side, right or not, dear? So let's do show IP route. So no information. Yeah. Now after some time we got some information available, right or not? After creating the indirectly neighborship, right or not? So can we ping that? Let's see. Ping 192.1, sorry, ping that is 200.0.1.1. So still there, sorry, 20.0.1.1. Just wait for a while. Ping that is 20.0 dot. So still, let's see, will it forward the data? No, they cannot able to forward the data, right or not, dear? Hello, show IP BGP. Okay, so we cannot able to forward the data. Still, these are in what? These are in the tables, but we cannot able to forward the data to other side, right or not, dear? We cannot ping the network available like ping 10.0.1.1, so we cannot forward able to forward the data, right? Because there is an issue with the reachability, right? So we have to parallelly configure all of them. So here we got the network information after the neighborship between these two R1 and R3, but cannot able to ping. So we have to configure with the another protocol. So router OSPF1 network, that is 10.0.1.0 0.0.0.255 area 0, okay, 10.0.2.0, 10.0.3.0 and 10.0.4.0. Okay, dear. And network that is 192.168.10.0 and 0.0.0.255 area 0. We have to provide, we have to do the configuration OSPF in this case. Let's go to router number 2. So router OSPF 1 network 192.168.10.0 0.0.0.255 area 0 192.168.11.0 and area 0. Let's go to router number 3. Okay. So configure terminal router OSPF1 network 192.168.11.0 0.0.0.255 area 0. Okay. And network that is 20.0.1.0 and 0.0.0.255 area 0, okay, 20.0.2.0 and 20.0.3.0 and 20.0.4.0. Okay. Now let's go to router number 1 and check the table. Okay. Show IP BGP. Now these are available in the table as we have seen. Let's go to a show IP routing table. What we have in routing table. So now in the routing table these are available. Okay. Clear. So 192.168.11.0 is also available. So let's give some time to update. It will take some time to update actually. Show IP route, show IP route, show IP route. Okay, dear. Show IP route. Okay. So we got the reachability now. BOBOBOB. Right or not, dear? Clear? Now we can easily able to forward the data in between them. Let's go to router number 1 and ping on other side ping 192 ping 20.0.1.1. So now they can ping. So that is means so this is what we call reachability, right? What? Reachability.